So if you've been programming for any amount of time, you've probably heard about the inversion of control principle. So what the inversion of control principle states is that a component should not be responsible for its own dependencies. It should get its dependencies externally. That means if you have something like a controller that can respond to an HTTP client, but it relies on some kind of tangible service doing something like retrieving a list of users, then the user's controllers should not instantiate that object. So what we have here is one method that is responsible for responding to the HTTP request, and then we have a constructor here. And the constructor says, I will take in a user service instance. So this means that elsewhere, if another class wants to instantiate a user's controller, then they have to first supply the user's service. And if the user's service depends on something, they have to supply that for the service. So each service will say, I require something. This is, of course, just completely normal object-oriented programming. But in .NET, we have a dedicated way of managing this dependency injection here. So let's say that you want to make sure that the service is injected for the user's controller. The place at which that actually happens is the program CS file, or wherever you're starting the web application builder. So notice that we have this line here that says that we're adding controllers. You will be inserting this line in order to actually use the controller's layout. But you're not actually instantiating the controllers yourself. This is actually doing the instantiation for you. So instead of you having to go new users controller and then calling a method like get users, the user's controller is instantiated behind the scenes. And since it requires a user service, we must also make sure that a new user service is instantiated behind the scenes, which is then being injected into the user's controller such that we don't have any compile errors. And we have a solution for this that is much prettier than this. So before you instantiate the controllers here, what you will do is write this syntax here, take the web application builder, and then go into the services here, and then they have a selection of different methods here. And the first one I'll just show you is one called add singleton. Add singleton takes in some kind of generic object here. So that could be the user service. And then as long as this one here is added to the web application builder before whatever is requiring it, then once what requires it is being instantiated, it just gets an instance behind the scenes. So if you go in here and you run this program here, .NET run, I'll just quickly show you what the service does. It writes a service instantiated, and then there's a list here that it gets with some hard-coded users. So we'll open up the browser here. And this is what we get. We get the hard-coded users here, and it says here, service instantiated. So if you request once more here, you'll of course constantly get the same object back here. But there are different ways of managing the lifetime of the service. So currently, it will only instantiate one service. But let's say that we want a different object for every request. Then we can go into the program CS file, and then we can change this to add scope. So if you're using a scope service, I'll just rerun this to show you. Then for every single HTTP request that your API gets, you will instantiate a new service object. So instead of the controller having to instantiate user services constantly, we just specify the recipe for which the web application instantiates services. You could also have the user service require something and then say, oh, here we want a different instance, not just for every request, but for every object that requires it. Then you would use, in that case, you would use something called transient. That's a transient service. When every single constructor that requires an instance of this instantiates a new service. So these are the three ones we primarily work with singletons, scope services, which means one for every request, transient services, which means one for every single object that requires it. And since we're also interested in decoupling the code, something you could also do is make an abstraction for your service. So in the context menu here inside of Writer, there's something called extract interface that you can use. And then you can just generate an interface based on a class implementation. So now I have an interface for my user service here. And now what I can do is add the iUser service here in front of the user service. And now the neat part is, if you require an iUser service, so you're saying I depend on an abstraction here instead of a concrete implementation, then you will get an instance of the user service. You could, of course, have many different concrete implementations, and the only thing you have to do is then you change the implementation here, and then you just automatically get whatever implementation you specified for your web application builder. So all of your different services inside of your program, they only have to specify the abstraction that they depend upon. And since nothing instantiates its external needs, then everything becomes much cleaner inside of your services. So this one is not responsible for instantiating a user service. It is just responsible for saying, I depend on an abstraction of a user service, and now the web application builder is responsible for actually injecting that.